All right, welcome everybody. It's good to see everybody. Welcome to our live data demo with instructor Michael Cullen. So excited to have everybody. So without further ado, let's go ahead and I will pass it over to Sierra. Sierra?
Thanks, Kelly. I'm going to share my screen, everyone. So just one moment here. All right, well, welcome everyone. My name is Sierra King, and I am the Admissions and Program Services Manager at the Data Incubator, and we are a fellowship, scholarship, and placement company. We have promised you another excellent info session today that will be led by one of our instructors, Michael Cullen, and Michael will link a notebook in the chat that he'll be using during his demonstration. So once that's linked, please make sure you have access so you can follow along. But to start things off, I would like to give you a quick overview of our program and everything that we offer. Then I'll hand off to Michael and we'll jump into our live demo, and then we'll come back at the end for some questions. Please place all of your questions in the Q&A section and we will answer them at the end of the presentation. As a reminder, our session is an hour long today, so if we don't get to all of your questions, please email us at admissions@thedataincubator.com and we will be happy to help you. So to start things off, a little bit about the Data Incubator and what we do here. So the Data Incubator focuses on training people to become data scientists and data analysts. And why is this important? Well, it's really because data scientists and data analysts have the ability to work with the latest tools on unstructured and structured data to drive business value. This is a big need in the world right now. We work with companies in a ton of different industries, and every company has data and wants to use that data to drive value for them. So there are a lot of other data-focused programs out there, so I'm sure you're wondering what we do at the Data Incubator that is a bit different. Well, what we found is when you're looking at training, there are two main types, one being fast-paced and efficient, and two being slower and focusing on understanding and completion rates. University is one example where you'll receive a more detailed understanding, but with a lot more time invested. And then on-the-job training is usually very quick and efficient, but maybe you're not fully understanding what you're doing. So what we've done here at the Data Incubator, if we take any aspects and combine them together to find a great middle ground for training. Our program is fast-paced. You'll walk out of the program knowing a lot about data science and data analytics and real-world business applications, and with a deeper understanding as you get from university. And all of our instructors are PhD and master's holders and have completed this program themselves and know how to provide that in-depth training that you are looking for. So we're so excited to announce that for our summer 2021 cohort, we'll be offering 3 data-focused programs. We'll be offering our successful full-time data science program, a more flexible version of that with our part-time data science fellowship program, and now our brand new part-time data analytics program. So like I mentioned, we are currently running 3 data-focused programs in our summer cohort, so we'll discuss the similarities in all of our programs. So all of our programs are intense. They are built around hands-on data-focused curriculums, and we offer both full-time and part-time. And both are packed with a lot of information and tools. Our programs are thorough. Each week focuses on a different data science or data analytics tool and approach. And in addition to our lectures, we have our students participate in hands-on practice. We really believe in fostering an interactive learning environment. And so in each program, students will work on a mini project that focus on that data tool that you are studying for those weeks. Additionally, all of our programs are very collaborative. We want our students not only to work with their colleagues and instructors, but also have the opportunity to network and connect with our hiring partners. Part of our data science program is working on a capstone project that you'll have the opportunity to present to our hiring partner network. You'll get some feedback on how to present, how to create a capstone with a clear business objective, and a great portfolio piece to add when you're interviewing with companies. All of our programs are career focused and that help you succeed in your data focused careers. You'll not only learn how to present your best self by attending our career search workshops, but you'll also have the opportunity to work with one of the #1 resume writing companies to get a polished resume and cover letter. And to help our students connect with our hiring partners, we host virtual network events and we do partner panels where companies will come in and talk about what it looks like to work at a company and discuss problems they're currently trying to solve. We will also host capstone showcases for our data science programs where students have the opportunity to present their projects directly to hiring partners. And lastly, all of our programs are interactive. Every student in all of our programs are provided a Jupyter server for the duration of the course. So students can follow along in lecture and see and edit raw code that's being run. And students will also receive immediate feedback via our interactive grader. Here's some information about our full-time data science program. Our full-time data science program runs for 8 weeks, and you're expected to attend lecture daily and be available for networking and additional group meetings from 9 a.m. to 5 p.m. And as I mentioned here is an overview of the curriculum. If you'd like a more detailed overview of the curriculum with the subjects broken down a little bit further, you can email us again at admissions@thedatincubator.com, and we'd be happy to send this to you. The part-time program lasts for 20 weeks with classes held on Mondays and Wednesdays from 7 p.m. to 9:30 p.m. Expect to spend about 10 hours per week outside of class, and office hours are also available each week. You'll receive the same excellent curriculum and training as our full-time data science program, but at a slower pace. And these sessions are live and instructor-led, so you're still able to interact with your instructors and peers and ask questions. As I mentioned earlier, we're super excited to announce our new part-time program for our summer cohort. Our part-time data analytics program will also last for 20 weeks with classes held on Tuesdays and Thursdays from 7 p.m. to 9:30 p.m. Eastern. And you can, again, expect to spend about 10 hours per week working outside of class, and you'll also have office hours available. And here's also a part-time data analytics curriculum overview broken down by week. If you'd like to see a more detailed overview, please again email us at admissions@thedatincubator.com. So we admit 2 types of students into our data science program. Fellows are offered tuition-free scholarships for our full-time program, and we offer a limited number of these scholarships to highly qualified candidates. Fellows are expected to leave any current employment to attend our programs and are expected to interview exclusively with our hiring partners. Scholars will pay tuition to participate in our program, and they are not required to interview solely with our hiring partners and may maintain any current employment. And scholars still have the same access to curriculum, resources, tools, and career services as our fellow students. And then full tuition scholarships are not offered for the part-time program. They will only apply to our full-time program. And we're also excited to announce our Data Analytics Diversity Scholarship Program, which aims to help remove barriers and provide opportunities for women, veterans, LGBTQ+, and students from racial and ethnic backgrounds that are traditionally underrepresented in technical roles. So if you're interested in applying for the Data Analytics program, you'll also have an opportunity to apply for this scholarship as well. So with that, that is just a little bit about our program. I will pass over to Michael for his live demo, and then I will come back on at the end to help answer any questions. And I will stop sharing my screen, Michael, so you can share.
Okay, thanks so much, Sierra. Get my screen share going here. And I'm also going to send out that link in just a second. So let's see in the chat. Where did that go? So we'll have I have a link for the GitHub repository where the code is located, but also to open up the notebooks kind of interactively, you can navigate to the following URL, which is going to open up a Jupyter Notebook server through Binder. And that way you can actually work alongside what we'll be going through. All right, let me start my screen share. So a quick overview of what we're doing today. Actually, I will say that if you go to that GitHub repo, you'll see all this stuff. We will be working in demo 1, Pandas Excel today. Recently, I've sort of been using both of these demos. That way people can catch, one of these events and stay on to either see, basically see the other one. So we'll be working through this first demo today, although you have access to materials for the other one, and you can peruse those, later, of course. And we will be working in this notebook. Now, what you will see if you open up that Binder link, after everything spins up your server, you will see that same directory tree, but in a Jupyter Notebook server kind of way. So go ahead and open up demo 1, and we'll be working out of this generate report notebook. So that's where we're starting here. And a little bit about today's activity. We're going to talk about using Pandas and Python. Pandas is a really popular library for basically tabular data analysis in Python, anything where we're working with tables. It's very fast, it's very efficient, and it's used all over the place. And we're going to be seeing how we can take Pandas, take in an Excel file, do some pretty non-trivial computations with it, and actually spit out another Excel file that has new kind of statistics and summary data that we have reported, along with the stuff that was in the original one. And our use case, so our sort of business problem we're solving, is we are looking at kind of a putting together or maybe augmenting an existing report tracking metrics for influencer marketing. I describe what the spreadsheet looked like right here, but actually I pulled it up in Google Sheets as well, just so that we could kind of see it. So there's two sheets we're working with, ultimately two tables. I'll show the posts one first. So these will be kind of the rows of data that we're working with. Might be good to zoom in. So each one of these rows represents a single post made by some influencer, like social media influencer, all synthetic data, names that I basically made up, but to emulate like a realistic data set. And so we have the day something was posted, the influencer who posted it. We have their number of followers. We can see this is not really being updated dynamically, which is I think meaningful kind of data quality issue we might think about at a different date, of course. We've grouped them by their number of followers, and then for each post we have unique to each post, well, the cost, how much we pay to get that post, and then the likes, comments, shares, and clicks for that. So in these clicks, we're saying like someone clicks through from their post, or maybe they go on our website and they use their code, they land on our website, and we'll say, hypothetically on our website, we want them to buy something. And we track that actually in this other table of conversions. And so here we're formatted in kind of a funny way, sort of like, in wide format, kind of pivoted out. And we're saying, okay, on, for instance, January 2nd, we had one conversion, basically one sale attributed to Brandon Gonzalez. Likewise, on January 6th, one of them attributed to Chris Washington. We have some missing values, which we're taking as zeros, but we have some zeros as well. And so this is kind of our data, and we are putting ourselves in the role of a data analyst or data scientist doing some kind of initial exploratory analysis for improving the way we report on this stuff. So that's our setting. And again, this just talks a little bit about those tables, what they look like. And just as an example, we're going to say that we've been asked by our manager to compute the following metrics, or to be able to compute these things. We're interested in cost per acquisition, and we're interested in conversion rate. And so what is cost per acquisition? Well, let's say in a particular week or for a particular person, I spend $500 on sponsored posts. Now, a bunch of people see those, a bunch of people maybe like and comment and click, but all together, only 4 people end up clicking onto the website and buying something. So as a result, I got 4 conversions for $500. I spent $125 per conversion, per person who bought something. So that's one of the things we're interested in. And then we're interested in conversion rate as well. And that's saying, out of all the people who click, what proportion of them actually buy something? So for some month or some influencer, if we got 100 clicks, but maybe only 3 of them make a purchase, our conversion rate is just 3% for that person. And why are we interested in these things? Why are we ultimately trying to track all the way to conversions? Well, we might look at things like likes, we might look at things like comments, we might look at clicks. We often might think about reporting like click rate, like we had this post and 100 people ended up on our website. But that doesn't really do anything for us if all 100 of those people didn't buy anything. So it's going to be it's sort of a commonly observed or commonly stated thing that stuff like click rate and certainly like number of likes and so forth, a lot of the time these are vanity metrics. And what we really want to know is we really want to get down to the heart of the business question, which is where should we be budgeting differently in terms of our marketing spend, right? Are there, in particular, the question we're going to try to answer is, maybe are there influencers who we're overspending on? And that's what we're interested in. Now, we might want to look at cost per acquisition per person. We might want to look at it per week or per month or overall. And so we're going to write some code that lets us compute these things in kind of a flexible way. Let's get right into it. So again, we're bringing in those Excel files. We're going to be using Pandas to do this. And I'm just kind of running some code here. Good. By the way, for those of you who maybe have not used these notebooks before, these are Jupyter notebooks, as you can probably tell. We have some Python code, and we have a lot of nice looking text that we've generated with Markdown, pretty ubiquitous tool in data science and kind of Python-based data analytics, also used with other languages as well. I will note, for each of these chunks of code, we can run them individually, but we can, the results will persist from, when we run this cell and then down to this cell and so forth. So it's imperative, if you are following along and trying to run the code, that you run every single one of these cells as you go along. You can do this by clicking this run button right here. You can also just hold shift and press enter, which is what I will be doing. And you'll see, when we run a cell, this number over here next to the text is increasing because that's saying this is the 6th thing I've run now. Okay, so always run your cells as you go through. This is a mistake I make every time I use one of these things. So here we're just saying, all right, if I don't have, I want to make this new folder, this new directory called reports. And this is going to be where I'm going to, export my results. And that's just saying, if I don't have that folder already, let's make it. Now I'm going to say, all right, cool. So the place I want to, well, first, I guess I want to open up my original data. So here I've said, well, I have this data directory. This is the folder where my Excel files live. And then I'm saying, OK, join that with the actual name of the file. And so I have a string for that. And then I'm going to read in, as we see read Excel here, what I got from that Excel file. Now I want to point out that I'm saying this is my posts. And I'm saying that I'm not getting the whole file, but a particular sheet. So we have to read in 2 separate tables because there are 2 separate sheets in the file. And so after doing so, going through my kind of first line of Pandas code for importing this thing, this is what we get. Of course, we can verify that it looks like this, and we're good. I'm saying posts.head and 2 to just show 2 rows of it so that it's nice and condensed. I'll touch on really quickly some things I'd see in the Q&A. Fermin asked how we enter text in the notebook. So if you are working on the notebook from Binder, and you can't do this in GitHub because GitHub is not interactive, so you would need to follow the Binder link. You can create a new cell by saying insert. So up here, insert cell above or below. Or as we see this A and B here, those are shortcut keys. So if I have like a cell selected and I press A, gives me a new cell above. If I have a cell selected and I press B, gives me a new cell below. There's certainly much more that could be said about navigating these notebooks, but we're on a little bit of a time crunch here. And I want to make sure we touch on the big ideas. Okay, so we have this date column, but right now it's just a string. It's just a bunch of like characters in a sequence. And we want to make it something a little bit more useful. We'll see later what that does for us. But I'm saying let's turn that date column into a date time kind of thing. And now let's load in our conversions. So it's coming in kind of the raw form we saw on our spreadsheet over here. And clearly this is going to need a little bit of work and massaging and transformation to get this usable. And so we'll have to do a lot of things. One thing we want to do is fill all of these missing things with a 0. Now, it's not always the case that that's the appropriate thing to do with missing data, but in our case, that's the assumption we're making, that it's appropriate to make those zeros. And now what we want to do, because we want to compute these metrics, right? And our metrics need things like conversions and cost. They need things like conversions and clicks. And really what we would like to do is take all this information and say, oh, Albert Taylor on January 8th had 1 conversion. It would be great if I could put a column in here, or maybe for Rachel Kelly on the 5th, maybe conversions next to clicks, right? So we want to reshape that conversions table, and then we want to merge it onto, attach all of the relevant rows to each other onto the posts table. That's going to make it easy for us to, get our 2 metrics we care about. And to do this whole thing with the conversions table, it's a little bit of work. We have it in this pivoted kind of wide format. We want it in a long format where instead of a column for date or a column for every single day, we have a column that says date, like we saw on the other table. And to make that happen, we are going to melt is going to be the name of this method here. We're going to melt our data frame down, and we're going to say keep this influencer column the way it is, but everything else squish it into 1 column. And so when I do that, and I'm also going to turn my new date column into a date time column, this is what happens. So this stayed because I said ID variables are influencer, so don't squish this one. But everything else, every other column gets squished. And I said, name that new column where I put them all together, name that date. And then now I have a whole bunch more rows. And then I've got a new column called conversions, because that's the things that we're in here, right? So that's our melted data frame. This matches up pretty nicely with our other table. And so we could imagine just taking Albert Taylor, January 1st, lining it up with the right row in the other table, and just tacking on this conversions number. And that's what we do right here. Posts.merge with melted. So this is my first table. I'm merging it with melted on these 2 things and on these 2 things. So I'm matching date and influencer to date and influencer. And here I accidentally, maybe put a lowercase I in this table, but that's okay because we can tell Pandas what the names should be. They don't have to match. So I melted my thing. It looked like this. I merged it onto posts, calling that df for data frame. And now here we are. So we have everything from before. Now, because we had a slightly different capitalization on influencer, that's now repeated. That'll be okay for us for now. We won't worry too much because we have conversions. And I can relate this now to clicks for my conversion rate. I can relate it to cost for my cost per acquisition. We're good to go. But we want to take everything we've done so far. We want to be able to do it again in the future, reliably. And if I wanted to do this for, another, let's say another Excel file, it would be a little bit silly to copy and paste all of those, blocks of code above and just change some strings around. So we're going to take everything we did and we're going to condense it into a function. So now I have this function called load and preprocess. I pass in a file path. And everything I did before, loading in posts, changing the date column, loading in conversions, melting it from wide to long, changing the date column there, merging the two tables together, all this good stuff happens when I just say load and pre-process the path of my original report. And just as a little reminder, report path here is pointing to, and you'll see something a little bit different because I'm running this locally, points us to our Excel file. So now I say load and pre-process my Excel file, and I still have my data frame just like before. Again, that's really nice. If I have more reports, I can just use this little line of code. And we're going to take that idea and we're going to apply that to computing our metrics too. For cost per acquisition, I want to write a little function that does that. And actually, we'll see a really interesting reason why that's useful. So I'm saying pass in my data frame. And I want to check, that I have some conversions because I don't want to divide by 0. So if I have some conversions, there's at least one greater than 0. I want to take my cost, add it all up, divide it by my number of conversions. And that's my cost per acquisition. You remember from earlier, I spend $500 on posts for people who actually saw that post, went to the website, and then actually bought something. Cost per acquisition is 500 divided by 4. And that's what we're saying right here. And, what I can do now is actually, I could say something like cost per acquisition on my data frame, and I could get, on average, over everything, overall, I'm spending $93 and about 62 cents to get somebody to buy something. But it would be, what would be really useful is if we could say, okay, what about for each influencer? Can I compute that separately, or, grouped by influencer names? And that's exactly what we have. So grouping by influencer, and then I'm saying apply, and I can actually put this function I just wrote that takes in a data frame and it spits out a number. And when I do that, we get this nice little list. Actually, it's a series, basically a column, saying that, okay, Albert Taylor getting, we're spending $29 per acquisition. Looks pretty good. Lori Young, on the other hand, we're spending nearly $1,200. And so some stuff probably starts to jump out at us as, oh, maybe we should investigate what's going on here, right? Maybe this is not the most wise use of our budget. But because we wrote this in a function, it's going to be really easy for us to group by other things. So I could say group by this month column. And month, that's something that we made where I turned this into January 2019 as a string. That's something that was actually done earlier, which I didn't go over in a lot of detail. But I can say group by that, group by that month and year combination, not by people, and then get my cost per acquisition. But I could even do something like group by month and influencer. And maybe to make this a little bit easier to see, I could even do something like this. And it's condensing a lot of that down, but that could say, in February, this was my cost per acquisition. So we have a lot of flexibility because we defined that as a function that we're applying to different groups. And also we have a lot of flexibility because Pandas is super cool. So that is cost per acquisition. Let's take the same idea and we're going to apply it in making our conversion rate. So conversion rate says 100 people clicked, 3 people bought something. So I have a 3% conversion rate. But that means I have to divide by clicks. So if there are 0 clicks, then I don't want to divide by 0. So I'm checking to make sure I have at least 1 click before I do anything. But then I'm just giving the number of conversions divided by the number of clicks, conversion rate. And, we could check this again. I could say conversion rate over the entire data frame, about 1.72%. I could take my data frame and I could group it by influencer, and I could apply that conversion rate. Now I could even take this and I could say something like, okay, well, can I sort these values? Like maybe like who has the highest conversion rate? Looks like Nancy Watson has a blistering 2.33% conversion rate. And Lori Young, who we saw in the other metric, who had that very high cost per acquisition, not doing as well, less than 1%, 0.08%, right? And again, we could imagine doing this for influencers for month. I guess maybe I might note, I think I called it influencer group. Not, what did I call that? Follower group. We could group by this and say, oh, well, if I look at, my major influencers versus my medium ones versus my kind of nano influencers, this is the number of follows. I can look at my metrics there too. So again, a lot of flexibility that we're getting. And finally, we don't just want to compute these numbers and have them sit in our notebook. Because we're sharing this data back with our manager, and maybe they don't use Python, they don't use Jupyter notebooks. They are kind of, Excel wizards, they're Excel native. So we want to be able to take all sorts of stuff and actually put it back in an Excel sheet, maybe as additional information, kind of additional stuff on top of the Excel sheet that we started with. And so to do that, I'm going to say, let's make a function called generate report. And this is going to do some grouping. And it's going to compute a whole bunch of little metrics on our data frame based on something that we're grouping by. And so now putting everything together, if I wanted to load in an Excel file and get a report split up by influencer, it's now 2 lines of code because I wrote those functions, which is very nice. And I end up with something like this. So I have my conversion rate and cost per acquisition, and I also just, to make things a little bit easier to, parse what's going on. I also looked at, the total number of posts, the total cost for that person, total number of clicks, and total conversions too. So my 2 big metrics and some, kind of helpful additional information. And, again, I can do that by influencer. I can do it by month. Actually, I think I might have a typo situation there. I can do it by follower group and all that good stuff, right? But the example we had there was by influencer. I know that I'm changing the notebook around a lot. It's just to demonstrate kind of little additional things and just to show the flexibility. All the big ideas are kind of already written there. And now we have this table, and again, we could do things. We could sort by some particular column. We could do a lot more work in Pandas, but what we're going to focus on now is actually just spitting that back into Excel. Well, okay. I guess before we do that, what if I wanted to say, who are my 5 people with the highest cost per acquisition, right? Our good friend Lori Young shows back up. And here, someone who we're spending nearly $1,200 to get somebody to buy something. And these other influencers are not doing so great either. I guess one thing I'll note really quickly, we wanted to take this and kind of do a little bit more investigation. I might say, okay, well, that's Lori Young, for instance, and I might want to say like, I don't know, port df. And I might want to say, I don't know, something like, and we could do this probably in a much better way, but this is just a quick example. So equals Lori Young, and that's because influencer should be with, that's supposed to be df. I could look at this and I could say, oh, Lori Young maybe was in this follower group. Maybe that's relevant, and maybe we should actually be putting that in here. But, it's kind of just a little bit of flexibility we have. But finally, we have this report we made. It's what our manager asked for. There's a million things we could do now if we wanted to, but we want to make sure we're kind of checking in, getting feedback. Is this useful? What else would you want? In a perfect world, what metrics would you have? What visualizations would you have? but we'll start simple and we'll just give them an Excel file. And so finally, everything goes back into one more function. And here I have this write report to Excel function. I'm taking in an input path. So that's, going to be this right here, which we defined earlier, report path. And then I have an output path. By default, it would just be called report.xlsx. But when I'm calling this function down here, I'm saying, let's put it in my reports folder. Let's call it this. And what happens in here? Well, that doesn't seem right. That should say conversions, but I guess it's not been an issue before. We load in, we do load in preprocess. We also load in our original data. And we're going to say, let's do a split by influencer. Let's do a split by month. Let's do a split by influencer and month. And let's take all those things and let's write them back into Excel. And so I'm going to open up this thing called Excel Writer in Pandas. And I'm going to say, cool, so write to my output path. And I want to put by influencer to Excel, give that a new sheet name. By month, give that a new sheet name. By influencer and month, give that a new sheet name. Finally, writer.save, saves the file. And so we do all this. And if we went back to our kind of file tree, we went in reports, and I've actually done this on another file. We would see that we now have this Excel file we want. Now you can't open this natively in a Jupyter Notebook server because Excel is kind of difficult that way. But what we can do is I can say, let's download this. And then maybe from there I could open it up, and I'll actually have to switch windows really quickly here. So I apologize for that. And so now if we, let's see, screen share, switch to Excel. And so now that we can see, and it's not styled very well right now, although there's actually a pretty rich functionality for styling Excel sheets in Pandas, something we talk about more in the fellowship and analyst program. But we've got three tables. I've got my influencer split. I've got my monthly split. I've got my split by both of those things. And I guess one thing we did not show, but which is actually very straightforward, just a few more lines of code, is actually taking the original tables and spitting those back in here as well. What makes all of this kind of useful? Well, for one thing, we have a pretty reusable tool here. If we had, let's say, I don't know, a whole bunch of historic Excel files from a whole bunch of different quarters, or maybe, we're doing them monthly or whatever it might be. I can use Pandas to, I could just actually, I could take everything I just did and I could run it on a slightly different file. So for instance, I also have one called Q2. And I could also say write report to file. And I'm just going to say, this is my report path now. And I could do that one as well. And, we would find, and I'm not going to take the time to show it, but we would find that we had all the same stuff, but for, a file that has like different months and maybe different people. And, we've also laid a lot of the framework for, after showing this to our manager, they say, oh, that's great. Maybe could we add this, or could I get a chart that looks like this? Or maybe even could we extend this further into, an app that I can just drag and drop my files into, or maybe can we extend this into a dashboard? Those are all ideas that we get into a lot more in the fellowship and the analyst program. There's a little bit of information, or there's an example of like that interactive app in the demo part 2 that you would see in this repository. But that is for another day. That being said, you can download this and run the demo yourself to kind of see that example. Okay, so that is my overview of kind of going from Excel into Pandas and back to Excel we have really just scratched the surface of what Pandas can do, given a limited amount of time. And, regardless of how fast I can talk, we are still racing the clock here. So I'm going to turn things back over to Sierra, who has a couple more details to mention about the program, and then we'll take some questions at the end.
Awesome, thanks, Michael. Let me share my screen again. All right, everyone. Well, just a little bit more information about our program. So a big component of our program that we really pride ourselves in is helping our students not only grasp data science and data analytics concepts like you've seen today, but also getting placed in that field. So our analyst program is brand new. We don't have any data here yet, but for our data science fellowship program, we see about 82% of our students are employed within 6 months of completing our program, and 97% of those students are working outside of academia. So those are really great numbers. We are super proud of them. We've worked really hard for them. And that's really part of the challenge, not only learning content, but being able to transition into a data science or analyst role. And that's where our program stands out, because we help you to do both. So where are our graduates now? Where are they working? What are they doing? Again, data is not available just yet for our analyst program, but for our data science fellowship program, this will give you an idea. Our graduates are working in 55 different industries. Some of the most common industries we see are computer software, internet, IT, financial services, and biotech. And then some of the typical job titles we see are data scientist, data analyst, research scientist, software developer, and product manager. These titles and roles vary depending on the company and industry, but these are just some of the roles we've placed in the past. And then here is a short list of some of our data science fellowship hiring partners. Many of these companies are also hiring for data analyst roles as well. And we are focused on building a separate network of hiring partners dedicated solely to our data analyst program. And if you'd like to see a more detailed list, we can send you a sample hiring partner list. So please email us at admissions@dateincubator.com and we can get this over to you. I've seen a couple questions about financial options and if we offer assistance, and the answer is yes, we do. Especially during times like these, it's hard because people may have extra time to participate in our program, but limited cash flow. So we want to help you with that. We've partnered with LEAP to provide an income sharing agreement. It's a really great option for a lot of our students. You can participate in our program with just a deposit down and won't be required to make any payment until you've graduated and are working and earning more than $40,000 annually. We also have traditional loans through SkillsFriend. They offer 3 different options, 1 being deferred repayment, 2 interest-only repayments, and 3 immediate repayments with a variety of loan terms available. And lastly, for many of our part-time programs, many companies are willing to sponsor or pay for their employees to go through our program. It's a win-win. You get to learn great stuff in the evening and be able to apply it to your job during the day. So if this is something that you're interested in or you would think your company would be interested in, you can also email us. We'll be happy to provide you a letter that you can send to your employer. So where are we right now in our admission cycle? Well, we run multiple cohorts a year, and our spring cohort is about 1/3 of the way through the program right now, but our application for our summer program is now open. Our summer cohorts will run for our full-time session from June 28th to August 20th, and part-time June 28th through November 12th. And as I mentioned earlier, the full-time cohort is 8 weeks long, and the part-time cohort is 20 weeks long. And some specifics about the data science application. We ask that you submit your application by May 7th, actually for both of our programs, so both data science and data analytics. You'll then have 72 hours to complete your data science coding challenge from the time that you open it, and the challenge deadline is May 10th. You can't complete the challenge unless you submit the application. So just in general, I recommend that you complete the application sooner than later to avoid any technical issues, because we can't reopen the application or challenge after the deadline. And then some more specifics about our data analytics application. It's broken down into 2 parts before we make a decision: the application plus the optional diversity scholarship if you choose to apply for it, and an interview. The application, again, deadline is May 7th, and decisions will be made on May 28th. And if you're interested in applying to any of our programs, which I hope that you are, you can go to thedataincubator.com/apply to submit your application. And if you have questions about your specific situation, this presentation, or going through our application process, please reach out to us again at admissions@thedatingincubator.com, and we'd be happy to answer your questions. We will drop that email in the chat for you as well. So at this point, I will open it up to the Q&A. So if you haven't put a question in there yet that you'd like answered today, please do so now, and we will start answering those. So it looks like the first one will be directed towards Michael. Will we be able to upload the completed TDI mini projects on our GitHub account?
Yes, so yeah, this being a question about the mini projects that you would be completing during the fellowship or analyst program, the answer is no. Those mini projects are like a core part of our curriculum, and we kind of like to keep them that way. So we don't, we require people not to publish, the mini project work, as well as, of course, not publishing like our kind of textbook notebooks. But you are certainly like more than welcome to, publish your capstone project and make it public facing. In fact, you are actually beyond encouraged to. That's actually like a requirement of it.
Another question here, it says, would the notebooks from today's session, I'm assuming, be available for personal review?
They are indeed, and someone just asked in the chat to post this GitHub link as well, so that's good timing. You can get them from this GitHub repository. You can clone the repo, or you could download it as a zip file, whatever works best for you.
All right, the next question, it says, would we impute data for those missing values or just zero those out?
So I'm going to give you one of my favorite types of answers, which is, I'm just going to say it depends here. This is like a kind of canned synthetic problem type that I made up, synthetic data that I generated, some random numbers. I don't know why there are some zeros and missing values, but we're making the assumption that a missing value there means that nothing happened. So it's a zero. In some cases, it's much more appropriate to, impute with averages or to interpolate if you have time series data. Can't answer it in general.
Another one here, these are a lot of technical questions today, Michael. It says this one, can you classify a distinction between melt and merge?
Sure can. And let me, this is, let's see, Chrome has put me in a funny situation here. Let me actually share my screen again really quickly. I think it's a little bit easier to just see it. So if I go in here, so I'm back in my report notebook, and down here is where we did melt. So I said conversions.melt, and I did a bunch of other stuff. But if I just did conversions.melt, so my conversions table, let's remember, is this one. And so if I said conversions.melt, and I don't even have to give any arguments here, I can just say like that. It's going to take that wide data frame and it's going to squish it into a long one. But the other stuff we put up here said, oh, wait, no, actually, I want to keep this by itself and I want to rename variable and value. So when I ran this with some arguments, melt did that. So it took my wide thing and it squished columns into separate rows by putting those columns together. Merge then took melted. And again, melted looks like this. And it took posts, which again looks like this. And it said, oh, influencer, date. That's a pretty good way for me to take conversions and just put it on the end right there. That's what we saw.
Okay, another question here. It says, can there be a situation where someone has a high CPA but is providing high returns on investments? If so, how can you measure that?
Sure. This is a, being a hypothetical, I'm sure there is a situation where this could be worthwhile. If we had more data, for instance, and maybe this is a conversation about whether we are exporting the right data here, or if maybe we could get it from another data source. It might be nice to know not just how many conversions, but let's say who those conversions are so that we can track them further, how much they spent on that particular purchase. Like let's say, we have someone who's only getting a few conversions, but the people who are coming in, they're buying a bunch of stuff and they're doing it over and over and over again. In that case, spending a lot on an acquisition is actually, that acquisition is more valuable because the customer lifetime value is much higher. I'm sure there are other hypotheticals one could cook up as well.
All right, and the next one says, is it best practice to save to Excel versus CSV, for example?
So you all are doing a great job of setting me up for my favorite kind of answer, which is that it depends. In this case, our use case was to give someone an Excel file because they work with Excel. In a lot of situations, CSV is probably more appropriate. For instance, CSV is something you can open effectively anywhere because it's just raw text. So for instance, I could have exported a CSV and then opened it, in my Jupyter Notebook server, which I can't do with Excel unless I use Pandas. But here our focus was giving someone an Excel spreadsheet. And so their Excel makes sense. One last thing I'll say, I have a tendency to kind of ramble, but if we wanted to give our manager a CSV here, we would have to give them like 3 separate CSVs, right? Because you can't have multiple worksheets in one of those things. So I couldn't give them a file where they could tab through from here to here to here. They would be separate tables. So that's one thing to think about.
All right, another question here is, how complete should the capstone proposal be on our application to be considered for the program? And are we required to stick to our proposal if we are accepted? So I'll answer the second part of that, and maybe Michael, you can go a little bit into what you're looking for during the interview, but you are not required to stick to your proposed project after your interview if you're accepted into the program. I think by best practice, we ask students to have their ideas finalized by week 1 because it's a lot more challenging if you attempt to change it throughout the program because you are assigned a capstone group mentor and a group that you're working with. So you're not required to complete the program with what you used to interview, but have a good idea by week 1. And then Michael, maybe you can talk a little bit more about the scope of it for the interview.
Yeah, absolutely. I'll say that, we see people coming in to the interviews in very different phases of their capstone project. And we admit people in very different phases of their capstone project. I have seen people interview with a capstone that they could turn in and satisfy the graduation requirements, and it's great work already. I've seen people who come in with a super compelling business case. They really know their problem inside and out, and they can really give a meaningful pitch. And that's, I don't know if I could say just as valuable as a capstone project that's maybe like done already, but the most important part is like having a strong understanding of the problem that you're working on, and really being thoughtful about, is this a real world business problem? Is this fixing or solving or improving something for somebody? Being able to talk about, let's say like this project that identifies credit card fraud. I'm not just gonna say like, oh, I'm finding credit card fraud, but I might be able to say something like, credit card fraud is costing like banks globally like $150 billion a year. 120 billion of that is due to not identifying fraud. But 30 billion of that is because we are falsely calling things fraudulent when they're valid. And so my project is looking at a model that does just as well at finding fraud, but a little bit better at, avoiding those false positives. That's like a very specific example. It's one that I heard quite a while ago, which I thought was a really compelling blend between knowing the technical problem they want to do and knowing why it matters and being able to talk about the impact. And I'll mention really quickly, because Fermin has asked this in the Q&A, help in designing a capstone project. One thing that I would do, it's helpful to look at, a lot of the typical examples you find on Kaggle and data science blogs, but I would also encourage, looking for like industry blogs, that are, not just like Python tutorials that talk about the way that different companies are using data science. And especially if, you're interested in going into ad tech. What does ad tech actually look like? What do data scientists do? What do they do in, I don't know, like, fintech, or what do they do in like the healthcare field? And, doing some domain level research on the problems and not just on like, the types of models people build and stuff like that. That's really helpful. That being said, you do have to carry out your project with data you can actually get, which is a little bit limiting, because you're not going to be able to get like protected, proprietary company data. But the best thing to do, like I said, is to research actually on the domain level.
All right, last call for any other questions. If you have them, again, please put them in the Q&A section and we will answer them. We have just a couple minutes left. And we also will be posting, oh, I see one in here. It says, does the Capstone project have to be something that has not been worked on before? For example, is it okay to take an application that has been worked on before, but explore different aspects of it or attempt to do the same application from our perspective?
Okay, sure. I would say definitely like don't beat yourself up over trying to find a completely new data science project with a completely new data set and all this stuff. There's a lot of people doing a lot of good work out there. You probably won't be the first one to think of something, and that's okay. But I would say, you don't want to do like the same project that a lot of people have done with like the same like, data set that's like one of the top 5 most popular data sets on Kaggle. But that being said, I see people who do just a very good job of, presenting and visualizing and building like good end products, even solving those kinds of problems. As long as they really understand why they're solving that problem. If you're predicting house prices, why are you doing that? It's helpful to talk about like how that's, something that people need to do because of property tax, not just because they want to predict them. So that's what I would recommend. Again, all the way back to the just domain knowledge.
All right, another question here. How many applicants pay cash versus income sharing, and will people doing income sharing have to pay some interest? So I will say, like Michael mentioned a couple times, it depends on each cohort size. It varies depending on how many students we have, but I will say that the income sharing is a pretty popular financing option for our students, but there are some incentives for students doing direct or cash payment. With that being said, the loan does not accrue interest and you're not required to start paying until you are working and meeting that minimum income threshold. Now this question I'm going to direct back to you, Michael. It says that Excel files are small enough to be stored on GitHub. What's the best practice if the raw data for our analysis is way too large to store on GitHub?
Sure. So I would say, and I'm going to knock out the 2 following questions on here as well. Yeah, GitHub is generally not somewhere where you should keep data. I have those Excel files in there because they're like little examples. For storing a data set that large, I mean, there's really a lot that could be said because you also have to be able to run computations on it. So it depends on what you're working with, but realistically, like the best place to store it is just in like a kind of bucket style storage place. Something like, Amazon S3 or like Google Cloud buckets, or just, Google Drive or Dropbox if you just need it like statically. Otherwise, maybe it goes into an actual database, but that's a whole other conversation. Going through the next 2. So you read that using Kaggle data is not as interesting as real data. Can I comment on that? A lot of the time, Kaggle data is real data. I mean, in the sense that it actually is something measured in the real world. But I would just say you should be wary about using a Kaggle data set to do the exact same thing that every single person on Kaggle is doing with that data set. And it's not that interesting to see someone solving a Kaggle challenge because it's probably one that, that's not identifying a problem. That's just going through like a fairly fill in the blank kind of, it's already defined for you. And then Adonis asked, what about capstone projects that are non-business oriented, healthcare and pharmaceutical research? Yeah, so I guess like with the phrase like business oriented, we use that kind of broadly. The best definition that I could give for it is that your project is useful and not just interesting. There is like genuinely someone who can use the results or the model. There is genuinely a problem that's being solved. It's something that, if I can predict this or find this or report this, then someone can do something better. More generally, healthcare, pharmaceutical, all those things, we can definitely think of those as, like those are certainly like industry. So maybe industry problem is more appropriate than business problem, if that's helpful.
All right, well, thank you, everyone. We are right at our time today. So if you have additional questions that we weren't able to answer, we did put our email address in the chat. So please email us at admissions@thedataincubator.com and we'd be happy to help you. Thank you, everyone, for attending today. We hope it was informative. If you haven't already submitted your applications, please do so soon. It does close on May 7th. And again, any questions, please email us. And thanks again so much for attending. Bye, everyone.